Good morning. Happy Monday. Today's lesson is going to focus again on system of equations, and we're going to determine which method is the best to use, and we're going to solve the equation. So I'm going to give 3 examples and we will go from there. I hope everybody had a great weekend. Okay, our first equation is x plus 8y equals negative 15 and 7x plus 8y equals negative 9. And from this we can see that probably be the easiest to do elimination because we have our coefficients, an 8 and an 8, and the easiest thing to do would just be multiply by negative 1 to get the opposite coefficient to be able to get that negative 8. So we're going to do that. We're going to multiply this whole equation by negative 1, and it's going to change it to negative 7x minus 8y equals 9. So then I'm going to write the first equation below it. Okay, and from there, by adding, I can eliminate my y variable because negative 8 plus positive 8 is just 0, so that becomes eliminated. Then I get negative 7 plus 1x is negative 6x. And then I get 9 plus negative 15, which would be negative 6. Okay, and from there, when I solve for x, I divide both by negative 6. Negative 6 divided by negative 6 is just 1x. Negative 6 divided by negative 6 is 1. So my x value is 1. Okay, so given that the x value is 1, remember I'm going to place it here and then solve for the other variable. So right above that, I'm going to put 1 plus 8y equals negative 15. And I'm solving for y. So I subtract 1 from both sides. 8y equals negative 16, and I ran out of room there, but I can tell you that that is negative 2. So the answer to our first system by using the elimination method is 1, negative 2. And again, I'm going to actually show us that same equation, and I'm going to solve it using the substitution method. So let me just go ahead and write those down. And we will solve it using substitution. Just to prove that indeed we could use either or of the methods. Let me just erase all this. Okay, so there's our solution. Again, this time we're going to solve using substitution. And we don't have y or x equal anything. The easiest thing to do is just go ahead and manipulate this first equation. And we're going to solve for x. So we just subtract 8y from both sides. We got x equals negative 8y minus 15. Okay, so now we've solved for one of the variables, and we're just going to plug it in to our other equation. So we're going to replace the x with negative 8y minus 15 in this equation. So we'll go ahead and down below that, I've got 7. Remember, we're replacing the x with negative 8y minus 15. And then we're just going to add 8y plus 8y minus equals negative 9. Okay, this probably isn't the most practical method for doing this. I like the elimination one better, but systems can be, just to prove that we can also solve it by substitution, I'm going to go ahead and do this. So distributive property, 7 times negative 8y is negative 56y. 7 times negative 15 is negative 105 plus 8y equals negative 9. Okay, and then from there, see how this is not the best method for this, but I'm just going to show you. You would just combine your y, so negative 56 plus 8, negative 48y minus 105 equals negative 9. Okay, and then, sorry for the shaky camera. Then from there we're going to solve for y. We're going to add 105 to both sides. Negative 48y, and then negative 9 plus 105 would be 96. And we just divide by negative 48. And we can see we're going to get the same value, y is equal to negative 2, and when we plug it back in, we'll get our solution, 1, negative 2. So that was just proving that it doesn't matter which method you use. I tend to like elimination better, but you can always use substitution, and it will give you the same exact answer to your system. Okay, so we're going to do one more example. And I won't show both ways, I'll just show you the easiest way. Okay, erasing the board. So this is our system. 6x plus 2y equals negative 6. And 7x plus 4y equals 8. So there's our system. Remember, we're trying to come up with an ordered pair that is a solution for both. This is a classic elimination one. Again, our x coefficients are a little bit different, 6 and 7. We just need to get an opposite of 4. Well, the opposite of 4, think about that. The opposite of 4 is negative 4. Well, how do we get a negative 4? Well, if we multiply this whole equation by negative 2, that's going to give us a negative 4. Okay? So, negative 2 times 6x would just be negative 12x. Negative 2 times 2y minus 4y. Negative 2 times negative 6 equals positive 12. So now we can solve using the elimination method. We're just going to add the whole equation. 7 plus negative 12 is negative 5x. Those eliminate because 4 plus negative 4 is 0. And then 8 plus 12 is 20. And we're going to get our x variable. Remember, do the inverse operation, divide by negative 5. That disappears because negative 5 divided by negative 5 is 1. So x equals negative 4. So we have our first part for the system. And I'm going to put the negative 4 right there and solve for my y variable. So let me just go over here and show that. So remember we said x was negative 4, so I'm just going to replace the x with negative 4 and then solve for y, and I'll have my answer to the system. So 7 times negative 4 is negative 28 plus 4y equals 8. Inverse operation of minus 28 would just be add 28. Again, you've heard me say this before, what you do to one side, you do to the other. So that disappears. 4y equals 36. Divide by 4. Y is 9. So the solution to this system is negative 4, 9. Okay, so give you a chance. You can pause the video, kind of review the steps. Again, the elimination method was the easiest one to use in that case. Okay, looking at my work. And I will do one final example. So let me just erase some of this. And our final system is negative 3 minus 3y equals 12x. And negative 5 minus y equals 2x. And I'm glad I did this one, because this is not in standard form. Remember what standard form is. It's x, y constant. And we just have to manipulate both equations to be able to get that. The question is, do you have to do that? Well, I'm going to investigate and see, but I don't think you do. And but let's give it a shot. So the 12 and the 2, well, how do we get the opposite of 12? Well, think about this. If we take 2 and multiply it by negative 6, that's going to give us the opposite of 12. Well, let's go ahead and do that to the whole equation. So our first equation becomes 30 plus 6y equals negative 12x. That's just following the rules of multiplying by negative numbers. Now write the other equation below it. And you can see I can eliminate the x variable by adding. We'll have to add throughout the equation. So 30 plus negative 3 is 27. 6 plus negative 3 is 3y. That equals 0. So can I solve for y? Yes, I can. I just have to manipulate the equation. So we did not have to get it in standard form. As long as you can still eliminate the variable, you didn't have to get it in standard form. As long as they were kind of lined up x, x, y, y, constant, constant. So 3y equals negative 27. Y is equal to negative 9. Okay, so we have our first variable. We've solved for y, so I'm just going to plug in. I'm going to use this one right here, this equation. Negative 5 minus y equals 2x. And remember, I'm replacing the negative, or the y, excuse me, with negative 9. So I have to be real careful when I do this. Just actually replace it. Don't forget about that negative sign. Now let's remember this. A negative times a negative is positive. So that would just be negative 5 plus 9 equals 2x. Well, negative 5 plus 9 is just 4. 4 equals 2x. And our x value is 2. So the solution to that one is 2, negative 9. Okay, kind of zoom out here. Make sure I have that. And as always, I can kind of visually check and see if that is correct. We should have balance, and we do. When you do plug that in, you can just replace the variables and you can see that. And that, my friends, is solving system of equations by elimination and substitution on Monday, April 20th. We'll do some more practice with this. Tomorrow I'm going to show us how to use Desmos to solve all these equations, make life a lot easier on us. And then we will jump into word problems. Have a great rest of the day. Thank you.